Hello. Thank you all for joining us on this edition of ACC Live. Today we're going to talk about the total solar eclipse. My name is Dr. Michael Endl. I'm an associate professor for physics and astronomy at ACC. So I teach astronomy, right, that topic that we are dealing with now. So the total solar eclipse is just around the corner on Monday. So let's dive into some of the most important questions about solar eclipses. The first one is basically, what is a solar eclipse? And what you probably know anyway is that our moon is orbiting our planet Earth. And that takes about a month. And the plane in which our moon orbits the Earth is very, very close to the plane in which the Earth orbits our sun. That takes, of course, a year. But occasionally, that leads to a very nice alignment that is seen from us, from planet Earth. The moon moves directly in front of the sun in the sky during the day. And that is a solar eclipse. That doesn't happen every month, simply for the reason that these two planes are not exactly perfectly the same. But it does happen occasionally, and it's going to happen, and we know this for absolute certainty, on Monday, April 8th. There are two types of eclipses. One is called a partial eclipse, and one is called a total eclipse. And some of you might wonder, what is the difference? So as the name says, a partial eclipse is only when the moon partially eclipses the sun. So it doesn't completely cover everything from the sun. It can be 99%, something that we had, for instance, last October. And then there is the total eclipse. And in this case, the moon covers everything of the sun, 100%. So the sun is basically completely gone from our view. And that is the so-called total solar eclipse that we're gonna have on Monday. And the difference between those two things, I can tell you, is literally night and day. Because even with a 99 partial solar eclipse, you can have still so much light reaching the Earth that it doesn't really get dark and you don't see all these fantastic awe-inspiring things that you see during a total solar eclipse. Another concept that you probably heard over the past few weeks is the path of totality. So what does that mean? Well, when the moon is in front of the sun, what actually happens is that the shadow of the moon reaches the surface of the Earth. And the core shadow, where you get a total solar eclipse, so where the moon really covers 100% of the sun, is actually a tiny area on our planet. It's not more than about a few 60 to 80 miles across, or 100 miles or something like this. So it's basically a black disk on our surface of the planet, and you have to be in that disk to see the totality. But everything is moving in space. The Earth is orbiting, the Earth is rotating, the moon keeps orbiting around the Earth. So what happens is that this black disk, this core shadow of the moon, moves very fast across the surface of our planet. And that path that this moon shadow is following, that is called the path of totality. So on Monday, you will need to be somewhere inside that path to be able to experience this awe-inspiring total solar eclipse. If you're a little bit outside, you only see a boring partial eclipse, which is really not much in comparison to the fantastic experience of totality. That is the reason why people with disposable salaries spend thousands of dollars on plane tickets to fly across the planet to get into the path of totality. And another thing is, which is amazing, is that this core shadow of the moon travels with almost 1,600 kilometers an hour across the surface of our planet. So it goes very fast, and that unfortunately means that the totality typically only lasts a few minutes for an observer that's kind of stuck on the surface of our planet. But even with a jet plane, you cannot really catch up with that shadow. You can maybe extend the duration just a little bit. Now let's talk a little bit about safety. Safety is super important for eclipses and for viewing eclipses. One of the things that is the most important thing is that you don't look at the sun unprotected. If you look at the sun directly, the sun is too bright for our eyes. That's why we don't do it usually. And you also don't need to worry about your pets. You don't need to worry about your dog or your cats or your guinea pigs to have any issues during the eclipse, because they're not going to stare into the sun. So we need this in order to look up into the sun during an eclipse. These eclipse glasses cut down more than 99.9% of the light and let only a tiny bit through to your eyes, and that allows you to view or to look at the sun safely. So you can even use them today and look at the sun when it's not eclipsed and you see a bright disk in the sky. But this is really important because the light is so intense of the sun that if you do this for a little bit longer, just staring into the sun, you damage your eyes. You can have permanent damage experiencing from just looking at the sun too long or completely unprotected. Another super important safety thing is that you never use anything that intensifies and focuses the sunlight. So do not use binoculars, do not use telescopes of any kind or anything optical in front of your eyes and look at the sun. This is even worse because here you can really blind yourself. So be very careful, don't do it. So if you use a telescope and you're, for instance, an amateur astronomer, they are aware of this. And there are, of course, safety measures like solar filters that we, for instance, gonna use on our telescopes at ACC on the 8th, that again remove more than 99.9% of the light. But if you don't have that, please do not use any kind of device when looking at the sun. And the last bit of advice, and that's also very important, is that surprisingly there are I've heard of people that went to a total solar eclipse, and you use this all the time until the moon fully covers the sun. So even if there's just 99.9% left of the sun, you still need this. But the moment finally the moon completely covers the entire sun, during what we call totality, you have to take these off. Otherwise you miss the entire show. So let's talk about what can you expect to see during totality. So prior to totality, the moon will slowly start covering up the sun. This starts actually here in Texas shortly after noon. And so you will see the sun getting smaller and smaller and smaller, and it gets darker and darker and darker. But it's not very obvious because our eyes adapt to darkness, and it's so slow that you wouldn't actually realize this until it gets really dark. And animals will start to react. You will hear the birds singing because they think it's the evening. You will see insects reacting to it. You might see your pets now reacting to this change in lightning. And then, and that's the big thing, when totality occurs, you have to take off those eclipse glasses because then it's absolutely safe to look up towards the sun. And what you will see is something that is just absolutely mind-blowing and awe-inspiring, and is something that you can't describe in. I've seen 2 total solar eclipses so far, but it's very hard to put into words. Well, the first thing is, of course, it's dark. But it's a weird darkness. It's not as dark as like midnight. And it's also not evening darkness, kind of dusk or dawn. It's something very special. And you look up and you see the outer parts of the sun's atmosphere that we call the corona in the sky, hanging there in the sky, like with a kind of silvery glow. That alone is amazing. But then you see stars. You look up and you see the stars in the sky. You see our solar system planets. You will see on Monday Venus, very bright beside the sun. And the other, Mercury, I think Jupiter's up in the sky as well. There's even a comet in the sky, but that one will probably require binoculars. And that's not it. That's not all of it. When you then look around, and I encourage everybody not to just stare at the sun during totality. You have like 2 to 3 to 4 minutes, depending on where you are. Look around, because when you look at the horizon, you will have a beautiful sunset colors around you, kind of orangey reddish, that then transitions like a rainbow into the darkness of the sky above you. So it's really absolutely mind-blowing. And then it's important that when totality ends and the first bit of the sun becomes visible again, that you put your eclipse glasses back on. Okay, I think we have covered quite a lot of important topics. Let's see if there are some questions from our viewers. I see, no questions yet. Okay, well then let me talk about a few other interesting topics about total solar eclipses or solar eclipses in general. One is, for instance, that you might have wondered already, why is it that the moon and the sun appear exactly the same size in our skies? The moon is a very different object than the sun. The sun is a star. The moon is just, a companion to a planet made of rocks, while the star is made of hydrogen and helium. The sun is obviously much, much, much bigger than the moon. It's actually 400 times bigger than the moon. But the moon is 400 times smaller. So the surprising answer to this question, why are they the same size in our sky, is coincidence. Just pure coincidence. We are lucky to have this. That our natural satellite, the moon, is in angular size, as we say, so how big it appears in the sky, the same as our sun, as our star. And that's just because those two ratios, by coincidence, match exactly. That the sun is 400 times bigger, but 400 times further away than our moon. Oh, I see we have a question. Go ahead. I heard that too. Yes, it moved very, very slightly. It did, yes, but I checked at least our locations here. It didn't seem to really have any effect on the Central Texas locations. And I actually don't know why it changed, because we typically, it must have been just a tiny, tiny amount. We typically know by now very well, things like the moon's orbit and the Earth's position relative to the sun and all these things. So there you go. First question, and I cannot answer it. Okay. Well, I have another question that I can talk about, which is that I get very often in preparation and in going towards this event, is how often do solar eclipses occur? The surprising answer is they're actually not that rare. They occur on average every 18 months, so 1.5 years. But, and that's the big thing about solar eclipses, they occur randomly somewhere on this planet, which spins all the time. So most of the solar eclipses occur over the Pacific Ocean because this is the biggest part of our planet. So they're not that rare, but if you stay put on one location on this planet, they become very rare. So on average, it takes about 400 years to be like back here in the Austin area and see a total solar eclipse again. So that's why this is for most people a once in a lifetime event, unless you're spending a lot of money to travel to the next one or the ones in the future just to watch them, just to see them. This on Monday might be the only total solar eclipse that you can experience in your own lifetime. So it's very, very important. Where can you, by the way, where can you get these? So you can pick them up actually at ACC campus locations. You just walk in and ask for them. We have distributed thousands of Eclipse classes on our various campus locations. And if you happen to be on a campus on April 8th, we have on 4 campus locations watch parties. This is at Highland, Cypress Creek, and Cedar Park, Round Rock location, and the South Austin location. And there you can just join us and celebrate this incredible celestial event. Let's just fingers crossed that the weather cooperates. Okay, we are so excited for this. We are really, really looking forward to Monday, and I can't wait to share this experience with everybody here. And I thank you all for joining today for this edition of ACC Live. And I wish you all a wonderful eclipse experience on Monday.